So you've got myself that will be doing a lot of the talking, unfortunately, sorry about that. So my name's Richard Stubley, I'm one of the process specialists. I actually work out of the Birmingham Tech Centre normally, but at the moment we're all home based. And then we've got Spencer on the call as well.
Hi everyone, I'm Spencer Hardcastle. I work for Autodesk. I've done it for 6 years, a tech specialist as well, and I'm home based in the north of the UK.
Cool. So yeah, as we say, we really want this to be as interactive as we can. Please speak on the chat. We want to know who's the closest to either of us. So I'm based out of a little town called Halesowen in the West Midlands. Spencer's up in Bradford up north. So we want to find out who's the closest and then who's the furthest away. Be interesting to see where everyone is geographically based on this. Hopefully everyone's staying safe at the moment, still being as productive as possible. I know I certainly have some good days and bad days at the moment, but yeah. So we're going to look at, again, drilling, tapping, hopefully give some tips of how you can stop yourself ever snapping a tap from inside of Fusion. And yeah, have a look at some of the things that I do on the machine. Again, I use machines quite a lot at the tech centre. We've got a load of CNC machines, and I'm mainly on our Haas VF2. So yeah, but I'm trying to think. I don't think when the last time I snapped a tap was, but I definitely still have the occasional faux pas. But hopefully we can look at some things in Fusion that you can put in to make sure that what you're running is as safe as possible.
Rich, we've got an Oklahoma in the house. Sarah Watts.
That's definitely the furthest away so far.
Furthest away so far. Come on, let's see you in the chat. Where are you based? Where are you watching from?
I'm more interested to see who's closest, to be honest. It's easy to get further away from us, but... So who's closest to Halesowen, which is slightly west of Birmingham, and then Bradford, which to me is just north. I mean, it's all a bit of a blur once you get up there. Past Stafford, and I'm not really quite sure. It's basically Stafford and then Scotland, in my opinion.
God's own county of Yorkshire it is.
Cool. Okay, so that's about 3 minutes in. Let's get cracking on this live stream then. So, this is the part. So, a little bit of history about this part actually. I hope some of you can recognise this very distinctive shape. This is actually the engine housing of a rotary engine. So back, what was it, last year or maybe the year before, we were given a task to internally within Autodesk make a load of samples that we can give out to people and show what Fusion is capable of. This was the one I did. This was a rotary engine. So I made the housing, made the piston, the eccentric crankshaft, 3D printed a couple of gears, and it actually turned and rotated. We have got a video on it. We'll post that in the description after we finish the live stream. And yeah, so I've just chosen that because I know this had some interesting drilled holes on there, and this will be quite a nice one to do. Also save me having to spend a couple of days prepping another demo, so I always like to recycle when I can. So we're going to have a quick look at this. So first thing I'll do is have a quick look at some of the holes and talk about the strategies that I'm going to use for them. So we can see we've got an array of holes going around the top. Those are all drilled and tapped M5. We've got 4 holes in the base. They're drilled and tapped M6. We've then got some holes in the side here. These aren't tapped, but these are both drilled. So that's a 16, and that's just a 6mm hole. And then those are drilled and counterbored 8mm holes, again, not tapped. So we've got quite a few holes, different setups. So we'll also be covering a little bit of 3+2. We made this on our DMG Evo 60. We made this. So that's got a 2-axis table, so a 5-axis milling machine. But of course, if you haven't got multi-axis, you just create another setup, position the part in that new location, and carry on again. So I'll cover both ways of doing it as quick as I can without boring everyone to pieces. So first thing I want to talk about is, do I spot drill or do I not spot drill? So this is something that I'm sure a lot of you could probably argue with me about, but I'm just going to talk about why I do it, when I do it, and different things on there as well. So yeah, let's just have a quick look at this. So, to spot or not to spot, that is the question. Also, anyone, if we're having any problems with the audio or video, please chuck that back in the chat. We'd rather fix it now than fix it at the end. So when do I spot or not spot? This is the sort of questions I ask myself. So is the face that I'm going to be breaking through at the very start, is that perpendicular to the whole axis? So you imagine if I've got a drill and I'm drilling down, is it perpendicular or is it on an angle? I want to know that, because that's a big thing, because effectively you spot a hole to start off that drilling process and hold that drill concentric. Because some drills can wander, so as it comes down and touches, it actually deflects off and wanders. Again, that was a little bit exaggerated, but you get what I mean. So that's effectively what we're spotting to do. We're spotting to give that drill a starting point. And the reason why the spot drill doesn't wander is they're normally much shorter, and also they haven't got as well defined flutes, so there's a lot more material in the body of the drill as well, so they deflect a lot less. So when do I spot? So I ask myself these questions. Is the face perpendicular? Yes, it is. So I now go, is it solid carbide? If it's not a solid carbide drill, I always spot drill. Again, I could probably get away without doing it sometimes, but it's just this blank questions I ask myself all the time. I then go, is it less than 4 times D? So some of you hopefully have heard of that phrase, times D. But for those of you that haven't, it basically means it's a ratio of the length versus the diameter of the drill. And this is how a lot of people buy drills, how a lot of people specify different things about the drills. So let's say I've got a 10mm drill, and a 4 times D means the length of that cutting portion of the drill. So not the complete length, from the back of the drill to the front of the drill, to the cutting portion is that 4 times D. So that's what I look at. Is it less than 4 times D, then I don't need to spot. If it's more, then I'll probably spot just to give myself a bit more reassurance that I'm not going to potentially have any wandering or even snap a drill. Because again, although carbide is very, very strong, it's also very brittle. So you might want to spot drill just to prevent that. Imagine you've got a 5, 6, even 7 times D drill. You only need a little bit of deflection, so over that length cause quite a large error. So that's the questions I ask myself. But then I also got another thing here where I go, is the face perpendicular to the whole axis? No, it's not. Is the difference between the whole face and the hole less than 20 degrees? So basically saying that I've got my flat face, I've got my drill, it's only 5 degrees, or it's like 40 degrees. So if it's less than 20, in my opinion, I'll spot drill it. If it's more than 20, I tend to mill a flat on. So actually, depending on the geometry, I might just, draw a line in fusion and contour and actually just bring the drill in from the side. Or I might even do like a little boring operation, helically mill a little counter bore on to start that drill off as well. It depends on the geometry. Again, I can't give you a scenario for everything you'll ever come across, but this is hopefully going to give you a bit of logic you can use on when to spot drill or not. I find it quite shocking when we go to people and we have a chat with them. They spot drill everything because that's what they do. You can save so much time by not spot drilling, especially now, tools are so much better than what they were 10 years ago. You don't always need to spot. So if you can't do without it, I would do without it. So hopefully that makes sense to everyone. Anything interesting in the chat, Spence? Anyone not with us so far, maybe?
No comments on the manufacturing content. We've got some far out locations. We've got Michigan, Mexico, Italy, Korea, Tokyo. Who else have we got? Vietnam, Russia, Oklahoma, from all corners of the globe.
What do you reckon, Vietnam or Oklahoma, where's furthest away from us?
I'm going to go Vietnam, but my geography isn't brilliant.
Do you want to get your ruler out on your globe and start measuring it? Yeah, Vietnam's 28 centimetres. So yeah, there we go. We can go on there as well. Cool. Okay, let's get back into Fusion and have a quick look at what we're going to do inside there. Cool. Okay, so I'm going to have a quick look first at just these real nice holes in the top. So I've got two schools of thought here. These are drilled, tapped, and also, you know, chamfered or countersunk, depending on how you want to look at this. So I could do this in one of two ways. I could either actually spot drill this, although this doesn't fall into my should I spot drill or not, because there's that little chamfer on there, I could actually use my spot drill to come down and put that chamfer on there as well. So I'm going to show both ways of doing this, one with using the spot drill as a spot drill, and one with also using the spot drill as a bit like a chamfer tool and doing it afterwards. So we'll have a quick look at both ways of doing this. First thing I need to do, of course, is have a quick look at my tool library, see if I've got the right tools in there. If not, I'm going to have to make them. So let's go to my tool library. So again, I'm making this on our hearth, and I'm going to quickly just filter out for my drills. Let's see what drills I've got in here. So I've got a 4.2mm drill, which will be my M5 pilot. So that's good, I've got my drill for that. Overall length, flute length is 30, which we'll double check, but I'm pretty sure that's going to cope with the length of my holes, or the depth I should probably say, not length. Then let's have a quick look for my right hand tap, and I've got an M5, there we go, I've got an M5 by 0.8. As a little tip to anyone who doesn't know this, on a standard ISO thread, the pitch will actually tell you what diameter to drill the hole at. So a 0.8mm pitch actually means that the hole is 0.8mm smaller. So that's why the hole that I drill is 4.2mm, because of the pitch being 0.8, M5, you get the point. So that's why I've got those two on there. So I'm just going to quickly make another folder on here, just so we can all see what I'm doing inside that. So let's call this drilling. Okay. Let's have a quick look about not spot drilling first and the way I'd go about this. So I'm going to choose my drill. I'm then going to choose that hole on there. Let's select my correct drill. So that's going to be back into here. Again, I'm going to quickly go cutting diameter, look for my 4.2, hit OK. That's perfect there. But one thing now to bear in mind, I've seen this catch a few people out, especially if you've got your default set very aggressive, is that hole starts here. But if you actually think about it, the raw material is going to be on this edge here. So if you've got your height set really aggressive, so if you've got like your feed height set to 0.25 above, you're probably going to actually plunge and cut when you get to that point there. So just need to bear in mind, if you have got your default set really aggressive, be careful when you've got a chamfered hole and you select it, because the whole top is that edge, not that edge. Of course I can change this. I can change my top height to a selection. I can set that face on there. So you might be able to just see that shadowed portion that the drill is going to go down. If I change that back to whole top, it's there. If I go back to selection and select that bit there, it shadows there. So again, just some little things that you want to do. Let's change this to 0. Oh, what have I done here? Top height. Change that to that edge and put that to 0. Perfect. I've gone to my whole bottom, and I'm quite happy with that. So that's just down there. I'm going to quickly just double check with the inspect tool how far I'm actually going down there. Let's just accept that toolpath. I'm going to go inspect, click the bottom, click the top. Oh, there you go, it's 14. So again, my 30mm flute length drill is going to be absolutely fine on that. Let's go again in there. Okay, there we go. So let's look back at our geometry. I could go around, I could select all the same diameter, which is going to pick all the same diameter holes that I've got on there. Out of interest, that's going to also pick them on different layers. So if I had holes at one height and another height, it's going to select them all. But I could also just say, just select the holes at the same top height, select the holes at the same depth. I mean, there's some pretty darn good tooltips there, hopefully, that you can see that's going to show you what your selection options are going to be doing. So I just want to go, I'm going to turn that off just because I want to start doing a couple of different things. And we're just going to do these 3 for now. Okay, hope everyone's happy with that. I'm just going to make this a little bit quicker. Again, we've just milled this flat, we've faced that off, so I'm fairly happy with that height on there. And I'm just going to drag that down, make this a little bit more aggressive. So I'm going to wrap it down right to that top height, and then I'm going to feed down from there all the way down to the bottom of the hole and back out again. Again, it's once you do get used to what your machine and your tools and your work holdings like, you can really start honing your speeds and feeds for drilling. Now, what kind of cycle type do I want? We're only going to really cover a couple in here. We're going to do drilling rapid out, we're going to look at chip breaking and fault retract. So drilling rapid out is the first one we're going to look at. That is just going to literally go in, feed all the way down, and then get the hell out of there as quick as it can. So that's what I'm going to do on that one. And I'm going to hit OK. And I'm now going to do the next couple. So I'm going to duplicate that. Right click and duplicate, or Control D for duplicate for any of you power users out there. Just going to select the next few. Again, that hole, and that hole. So I'm going to talk about chip breaking now, and why would we use chip breaking against why we wouldn't. So chip breaking you can also probably call chip evacuation rather than chip breaking as well. Hopefully you've got your speeds and feeds dialed in so the chips do break. But also you've got to get those chips out the hole. Of course, if you've got through fluke coolant, that's going to be absolutely perfect. You know, you're going to be pumping that coolant in right at the drill tip, blow those chips out from the front, well, from the drill tip out the hole. That's the best kind of coolant you can use. But unfortunately, not everyone's got the luxury of through tool coolant. Christ, say that a couple of times. So what we might have to do is what we call chip breaking. So yes, this does break the chips. But to be honest, in today's day and age with modern tools, it's more about chip evacuation than chip breaking. And what this is all about is what we call pecking. So some of you might have heard it as peck drilling before. And what we do is effectively we're going to go down so far, and then we're going to retract a little bit, then go down some more, retract a little bit, down some more. And it's that little retract that we're going to do that's going to encourage the chips to come back out the hole and actually free up room so coolant can get back in, or other chips can evacuate as well. Now this was made in aluminium. I want to make it clear that's aluminium, not aluminum. And I probably offended half the people on the call there. And this is actually quite a difficult material to drill at times because it's so sticky and got quite a low melting point. You can actually have problems where your chips actually almost weld themselves to either the hole or to the drill, and then they just basically bind up and you need a snappy carbide drill. Again, carbide's really strong but really brittle. So yeah, again, anyone, I'm famous for just not stopping talking. So please post questions in the chat and Spencer will interrupt me if he feels needs to. So I know my hole's 14mm deep. I'm going to probably go on here, pecking depth, I'll probably do little 5mm pecks. Minimum pecking depth, pretty much as explains what's the smallest peck you're going to want, because what it will do is it'll actually try and average out the pecks throughout the cycle, so you haven't got like a 5mm, a 5mm, and then a 0.5mm peck. It will try and average it out. And then an accumulated pecking depth. This is how many pecks do you want before it does a full retract. So this is like a combination. I want to go down the whole depth. I know my hole's 14, so I'm just going to put that at 18 just so I know I'm clear. And then when it actually does those pecks, how far back do we want it to retract before it goes drilling again? 0.1 is a good one for me. Some people also like to put a dwell in before that retract, so it stops while it's still rotating, and that does break the chip off quite nicely as well. Then it does a little retract, then it goes down and drills again. Again, there's so many different options here, but you just got to find out, you know, what works best for you. So that's what we've got on there. Right, now the final one, which is a little bit easy when we've just looked at all those options. So let's just duplicate this. Edit. Let's choose my next three. I'm going to go 1, 2, 3 on there. Cool, so that's those three. Then I'm just going to look at my cycle and go full retract. Again, peck depth 5mm. And then what's going to happen here is once it goes down to that 5mm, it's going to retract the whole way back out the hole and then come back down again. So the peck depth reduction is actually how much do you want that peck to reduce the deeper down you go the hole. So what I might want to say is I've got a really bad problem with coolant flow. You know, I haven't got a really good coolant pump. It's struggling to get the coolant in there. So the deeper down the hole I go, effectively the worse my machining is going to get. So for every peck, I want to reduce the peck by 1mm. If you get what that means, effectively it's going to go, right, I want to go down the first peck at 5mm, the next peck at 4, the next one at 3, 2, 1. That's effectively what we've got on there. Again, you can play with those options all day long, but hopefully that's given you a little bit of an overview on those few little drilling types. How are we doing, Spence? Everyone happy?
Everyone's very happy. You're getting some love about your tips and tricks. The diameter trick particularly. The Control and D for duplicates also getting some love.
There we go.
I asked in the chat what people have been using Fusion 360 to make recently. Yeah. We've got somebody Alessandro's been making some sprue cutters. Nice. Ted working on a quarter scale windmill.
Ooh, I like that. Cool.
So yeah, let us know in the comment section what you've been using Fusion 360 for recently. We'd love to know.
Yeah, brilliant. Thanks for the interaction, everyone. It makes it a lot more fun for us rather than me just waffling on about drilling and tapping for a bit. Okay, so we've drilled all those holes. Let's get on to tapping them now. But I want to just quickly cover one first thing. We look at this hole, and the designer has done a lovely job at designing this. I mean, I designed this part, so it was my fault. Putting that thread the whole way down to the bottom of the hole. Now, anyone that knows anything about machining knows that's impossible. You know, unless you want to grind your tap completely flat off at the bottom and wind that all the way in, and then you'll inevitably snap it at the bottom of the hole. You just can't do that. So I've now got to make the decision, do I drill the pre-drill hole deeper and tap to the full depth? Or do I drill the hole at the depth on the model and bring that tap up? Because you never want to drill to the same point and then tap to that point, because you will snap the tap. So you will. I'd probably put a little bit of money on the fact you're going to snap that tap. You know, the tap needs to have a little bit to go. But yeah, so we're going to have a look on here. So what I'm going to look at doing is I'm going to probably... I know I was using 10mm cap heads on there. It's a 14mm hole, so I know that I can bring that tap up a little bit rather than having to go on there. Okay, so what I'm going to do, let's go in and let's go drilling. Let's select my tool, and then I'm going to go back to type. Tapping on the right, hit OK, and then I'm going to choose that M5 tap on there. I nearly choose the M6 one then. Choose that M5 tap on there. Choose my geometry. I'm just going to choose 2 holes on here. I'm going to waste too much time on this. And then in my heights tab now, I'm going to do my whole bottom, and I'm going to go up 4mm. So what you can see there, of course, that's right at the whole bottom, but I know I don't want to go down that full depth because otherwise I'm going to snap my tap. I'm just going to work back up 4mm. So yeah, so that's something that's quite nice on there. You can just bring that back up and then know that your tap's going to be safe on there effectively. So yeah, hope everyone's happy with that. That's all I can really cover on tapping. There's not much we can do to control the different tapping cycles. There's one. It goes in one rotation, and then it will rotate back up in the reverse. So if you've got a left-hand tap, it will go counterclockwise first, then clockwise to reverse. Right hand is clockwise, then counterclockwise. But please make sure that you never actually get to the point where you tap and drill at the same depth. So yeah, can't stress that enough. So again, what about these chamfers on these holes? So I'm going to make myself a spot drill because I know I haven't got one. So I'm just going to click on make myself a tool here. So make myself a little spot drill. And then again, depending on the angle, I'm going to actually go for a 90-degree tool here. This is effectively like a chamfer tool, but just with probably a little bit of a different flute. I'm not going to play around with the other settings. I'm not running this on the machine, so I'm not going to worry about the post. Hit OK on that. So, if I wanted to spot drill these holes first, I go back into my drilling. I'd choose my little spot drill I've just made. Choose that one there. and now I'd set that face. And what it's going to do is it's going to automatically work out the depth it needs to put that drill to get that spot in the right place. And that's quite nice on there. So you see it's got that intersect on there. That's because this angle's different. So that's one thing to bear in mind. The angle needs to be the same really between the two, unless you're going to make a part that's not respective of the model. So you can see, but it's worked out the depth it needs to bring that drill tip to match this bottom edge on there. So I'd now have to work out, as the modeler, model the wrong chamfer on there, or do I need to get a different spot drill tool? So again, you have to have a quick look and see what you need to do on there and work it out. I'm just going to do those two on there. Let's bring that one back up to here. So that's going to spot drill, then that's going to drill, then I'm going to tap. So again, that's how you do it on that way. If I then want to use that spot drill more as a chamfer and do it afterwards, I should probably actually do this right, because I'm cheating, I'm not doing the other hole. Let's do that other hole, there we go. If I wanted to do more as a chamfer, I'd come in and use 2D chamfer, because of course everyone watched the live stream last week on chamfering that we did. Out of interest, anyone in the chat actually watched that last week? Or is everyone here first time this week? I'm just going to choose that little bottom contour 3 times for that 2D chamfer. Set my chamfer which was 0, as I said last time, and I'll put my tip up offset as 1. Hey, I got a warning, let's have a look what that is. Empty toolpath, no passes to link. This is Spencer's favourite error message ever. So what that's basically saying, there's something in these options that's stopping that from happening. I reckon it could be the linear leading distance. So let's actually turn that off. I just want to see what happens when I turn that off. Does it work? No, it still doesn't work. Let's have a look now and let's start playing about with my geometry. So passes, let's go chamfer tip offset. I'm going to drop that down to 0.5 mil. Let's see what I get. Still get nothing. I only ever change one thing at a time, because if you change 2 things you don't really know what's caused it. 0.5, let's hit OK, see what we get on there now. Still nothing. This is really fun. No passes to link. Invalidate clear toolpath. Let's have a quick look, see what I'm missing. I must be missing something nice and obvious. I know what it is. I've chosen the wrong contour. Let's choose the top contour. If I'd watched my own live stream last week, I'd have known that you choose the top contour, not the bottom. So there we go. That was embarrassing, wasn't it, everyone? So there we go. So that's going to be a chamfer after we drill. So the spot drill is effectively a way of chamfering it before we then drill and tap it. Or we can then actually run the chamfer toolpath with the spot drill, do it afterwards. So again, completely up to you, whichever way you want to do it. You just have to sort of weigh up on your part what's going to be the best way of doing that ordering. So let's quickly flip over to some 3+2. Again, we've now got these on this edge I'm going to do. So we've got a multi-axis machine here. So what I can do is I can just go in and drill in from that angle. So I'm going to then do another drilling. I'm going to go geometry, tool orientation, and choose something that's perpendicular. I could either choose the whole axis or that face. And then I'm going to choose that whole face, select same diameter. Let's go in and choose the right tool. So I hope I've got an 8mm drill. If not, let's make one. I haven't got an 8mm, so let's make one. Let's quickly make an 8mm drill in here. That's a little bit long for my liking. Let's put that at 40mm. There we go, that should be all right. Again, really quick, I should be there doing lots of other things, but I just want to get through the content with you guys. One thing here is it's going to stop that drill point at the bottom of this hole, but we can see that this is a through hole. So what I'm going to do is I'm going to go into my heights and I'm going to tick drill tip through bottom and then say a breakthrough distance of 3mm. So what it's going to do is it's going to drill the tip through the bottom. If I put that at 0, you'll see what happens here. It drills just the tip through as far as it needs to go to break through the hole. Then what I can do is on the breakthrough put a little bit extra to then make sure that some good portion of the flute actually comes through. So that's effectively what I've done there. I've drilled the tip to the bottom and then carried on going a little bit more further on down that hole just to make sure that my flutes do a good bit of cutting. So that's an example of how I would have done those holes. Again, something to remember on here, depending on what your order of your operations is if you haven't counterbored this already, you know, you're going to be starting feeding here. Again, people with really aggressive heights on there might find themselves with a problem that they're going to start rapiding in to this point here, which is of course below where the surface of the material is. So that's just something to bear in mind, because what I would personally rather do on here is I'd rather drill this out first, then I'd use an end mill to mill that counterbore. So that's what I'd rather do on that. Because the whole reason is when you helix with an end mill, it's really bad for the tool. So yeah, that's what we've got on there. Okay, so that's 2 holes at tool orientation. Right, what I've got now is, let's have a quick look at these bottom holes. So we can see that if I look at, there's this tool called look at, I can look at that face. That's really cool. So if we just say that again, I can look at a face. And then what I'm going to do now is I'm going to look at this hole, and I can quite happily see that that hole is definitely not perpendicular to this face. So I'm going to need to spot it. Let's pretend like I haven't got a multi-axis machine now. I'm going to have to make another setup. And then I'm going to say that, you know, it's probably going to be, my Z plane is going to be perpendicular to that. Flip that up, pop that there. Okay, yeah. So again, I've got a 3-axis machine, so I've probably parallel milled that with a ball nose to get that at that angle if I haven't got a multi-axis machine, or maybe I actually did that in a previous off. Maybe I did a contour with it in that direction and went down it with the edge of the tool with the flutes. So what I'm going to do now is just go back into my drilling. I've got my little spot drill selected here. I'm going to choose that geometry on there. So I want to choose selected points now and just choose that point. There we go to. So that's now going to effectively drill down to that point, and I want to go a little bit lower than that. I want to go like 1/2 mil down there. So that's now going to spot those for me, so I can then go in and start to drill those holes. So that's how I'm going to spot those, because again, it's at that weird angle. You know, if we look right on the model, we can see we've got an angle on there. So I'm going to go in, I'm going to spot those holes, make sure I've got a nice starting point for my drill to go in, and then I can then drill to the full depth afterwards and then tap it as well. So yeah. So again, lots more holes on here. I could bore everyone by going through and doing lots of these holes. But I think that's probably going to be enough to get you started and show you some tips and tricks. Is there anything anyone thinks that they needed me to cover that I haven't? Please pop that in the chat. And again, I'll try and watch this YouTube chat or the comment section, I should say, for a couple of weeks. So even if you're not watching this live, pop your questions in there and we'll do our best to answer them. But yeah, we really appreciate everyone for tuning in today. But yeah, is there anything on the chat, Spence, that is interesting? Yeah. Okay. Yeah, that sounds good. Okay, well, yeah, cheers everyone. We again really appreciate you tuning in. If you want to see more of these live streams, please subscribe. We're going to try and do them every Thursday around the same time. We are going to change a couple of the times depending on some other commitments, but as best as we can, it's going to be this sort of time on Thursdays. We've got a few topics in mind, but we'd much rather you suggest them. At the end of the day, you're the ones that are watching them, not us. So please, if you've got topics you want us to cover, we do specialise more in the manufacturing side, but we can either do it ourselves or get some other people involved. I think I'm doing an FFF one with one of our 3D printing specialists next week. So yeah, stay tuned, and we really appreciate it. Cheers, everyone. Thanks very much.